All right, in this last example, we've got a series of functions which are essentially sums and differences of or variations of power functions with constant multiples, and we're going to use all of the rules we just learned for power functions and for sums and differences and constant multiples of functions to find the derivatives of these functions. So this first one is pretty straightforward, right? We have a constant multiple times a power function. So if you recall, the derivative of a constant multiple of a function is a constant multiple of the derivative. So what we can do is just hang on to that 3 and then take the derivative of x to the 4th, right? So we're going to multiply by 4x cubed. All right, now we can rewrite that as 12x cubed. All right, so that's the derivative of 3x to the 4th, right? So it's very similar to what we did before, only now we have a constant multiple of a power function. All right, so let's look at the next one that get progressively more difficult. But so remember, we get an x squared in the denominator, which I can change into a negative exponent, right? But we also have 1 over 5. So this is really the same as 1 over 5 times 1 over x squared, right? So be careful about, don't just flip that 5 up to the numerator. That's really 1/5 of 1 over x squared, and so that's 1/5 times x to the minus 2. So now we have a constant multiple of a power function, and we can write g prime of x is equal to, and I'm just going to bring down the negative 2, and I'm going to go ahead and multiply it times that 1/5. So I'm going to get negative 2/5, right? When I multiply 1/5 times negative 2, and then I'm going to subtract 1 from the exponent, so I get negative 3. All right, so there's the derivative of that one. All right, so this one's just a polynomial. All right, so remember, now we're going to use the rule for the sum of two functions. So remember, the derivative of a sum is the sum of the derivatives, and so h prime of x is I'm just going to take the derivative of each term. All right, so I'm going to get 2x, it's the derivative of x squared, and the derivative of 5x is just 5. And then the derivative of negative 12 is 0, because that's just a constant. All right, so that's it. That's all you need to do is just, if you have the sum of functions, you can take the derivative of each term in that sum. All right, now this one is, it doesn't quite look like something we're ready to do. We don't know anything about what's the derivative of a product. And you have to be careful, because even though the derivative of a sum is the sum of the derivatives, doesn't work for products. The derivative of a product is not the product of derivatives. Okay? No. No. You're going to learn a product rule in 109. But for right now, what we have to do is just FOIL this out. We're going to get 2x squared, and then we have a negative 4x plus 3x, so we have minus x. And then negative 2 times 3 gives us a negative 6. So if you just FOIL that out, now you've got the sum or difference of power functions, or you have a linear constant function, right? So we just need, now we can just take the derivative of each term. So p prime of x is equal to, okay, got to use the power rule, and then I'm multiplying it by 2. So I'm going to get 4x, right? And the derivative of x is just 1, right? So that's just going to be a minus 1. Derivative of the negative 6, right? That's a constant, so that's 0. All right, so there we go. Now we've taken the derivative, but we had to turn that product, right, into a polynomial in order to do that. Don't get it trapped into the taking the derivative of each factor in the product. That doesn't work. All right, so here's another one. Now it's just got 3 in the numerator. We need to rewrite this so that it's a little cleaner. So we're going to get 2/3 times the square root of x, which is x to the 1/2, right? And then plus 4/3. Okay, Now it's just the sum of functions that we know how to take the derivatives of. So h prime of x is going to be, I'm just going to bring the 1/2 out front and multiply it times the 2/3. Okay, so I get 2/3 times 1/2. And so that's going to be, well, why don't I just write it out, just make sure I'm not going too fast here. So I'm just going to bring the 1/2 down and then subtract 1. So 1/2 minus 1 is a minus 1/2. And then the 4/3 is just a constant. But I probably want to rewrite this. I can sort of just cancel these 2's, right? I have a factor of 2 in the numerator and the denominator. So this becomes 1/3 x to the minus 1/2. Okay. All right. Now this next one, again, we need to write it in terms of power functions, something that we know how to take the derivative of, right? So this is x to the 1 times x to the 1/2, right? So I can just write this as x to the 1, x to the 1/2. And then minus 2, whoops, let me do it this way, 2x to the minus 1. But I need to combine this, right? So I can add the exponents, right? Because they have the same base. So I get x to the 3/2 minus 2x to the minus 1. Now that's just a rewrite of the original function. I have not taken the derivative yet. And so now I can find the derivative. Let's call it dy dx, dy over dx. And that's going to be, I'm going to use, just use the power rule. I get 3/2 and then x to the 3/2 minus 1, which is 3/2 minus 2/2, which just becomes a 1/2. And then on the next one, I've got a minus 2. I'm going to bring the negative 1 down front, which is going to make it a plus 2 when I multiply. All right, and then I got x minus 2. All right, x to the minus 2 power. All right, so there you go. Again, like I said, there's a little warning here at the bottom. The derivative of a product is not the product of derivatives, and the derivative of a quotient is not the quotient of derivatives. Okay, you're going to learn product and quotient rules in 109, but don't get trapped into thinking that works. Now, for sums, it's nice. The derivative of a sum is the sum of the derivatives, but that does not work for products and quotients. So just be careful. You've been warned, right? All right. Well, that's all I have for this section, and I'll see you in class.